Thank you
Good.
everyone for joining us. Hope everybody is safe and sound. Welcome to Microsoft Reactor livestream event. My name is Rashmita and I'm the Bengaluru Reactor event planner. I would now like to welcome Mudit Singh, our speaker for today's session. Mudit is a product and a growth expert with over a decade of experience in building great software products. Part of LambdaTest founding team, he has been deep diving into software testing processes and working towards the aim of bringing all testing ecosystems to cloud. Today's session will run approximately 60 minutes with Q&A session. Mudit will try answer all your questions in between or after the session. Next slide, please, Mudit. Thank you. Before we get into the session, quick word on our code of conduct. The key thing to take out here is to be respectful of other people's views, understanding of differences, and kind and considerate in the way you engage. The chat will be open throughout, and we do encourage you all to participate. If this is your first time joining Teams live session, please note there is a 30-second delay from speaker to audience. So feel free to post all your questions in the chat, and speaker will get back to you. But for now, I will hand over to Mudit to begin the session. Over to you, Mudit.
All right. First of all, thanks, Rashmi, for conducting this session, hosting this session, and for the Microsoft team as well to inviting me for and giving me a chance to present LambdaTest and Azure DevOps as well over the platform here, Microsoft Reactor platform. And really appreciate it, everybody taking the time out to attend this webinar today. So these are unprecedented times. I'm quite sure there would be some kind of challenge either in your family or families of your known one related to Corona. But I really sincerely hope that all of you guys are staying safe, staying indoors. And again, it's really great for me if you guys took the time out to attend the sessions even in these kind of times, right? It's a win for me. So to give a introduction about myself, I am Mudit. So that's my photo. I cannot show my live video because of again a lockdown. I do not look like this anymore, right? So I am director product and growth at LambdaTest. We have been building the LambdaTest platform for around 4 years now, and I have been helping in both product side, marketing side, and overall, I connect with one-to-one with teams to understand what their issues are and help them solve their testing related problems using Microsoft team platforms, LambdaTest platforms, and other integrated testing ecosystem, right? So in today's talk, we are again going to do a deep dive into testing. So I would be focusing more around continuous testing and how you can do continuous testing at scale using LambdaTest platform, and how you can do continuous testing at scale using other Microsoft products like Azure DevOps, GitHub Actions. And then in the end, I'll be giving a small brief case study of how enterprises or how small companies are using an integrated testing ecosystem to boost their productivity using Microsoft products and LambdaTest platform, right? And at the end of the session, we'll be also doing a Q&A. So if you have any questions, feel free to post it over the Q&A session window right now as well, the Teams Q&A session. So during the presentation, as well as I get time between, I will be happy to answer any questions. And at the end of the session, we will do a dedicated Q&A session as well, right? So yeah, so with that out of the way, let me start off with the first part itself. What exactly we would be doing here is that I will be giving a step-by-step process of how you would be bringing all your testing workflows or your testing ecosystem to the cloud infrastructure. So we will start off by first understanding what exactly we mean by continuous testing itself. Right, so it's a term that has been around for like many years right now. There are multiple definitions of it that you will get it, but ultimately continuous integration starts with test automation itself. Continuous testing starts with test automation itself, and to understand continuous testing, we need to understand why test automation is important, right? So it started with when people started going into the agile development methodology. So agile development methodology was a very great software development process, specifically for new teams, small teams who had to only launch few set of features, and based on the launch of those few features, they got a feedback that yeah, this product is working. Now we can work on more features. So instead of spending years building one feature set, like one complete product and launching it and getting a feedback, they were now launching one small features, getting a feedback, and based on that releasing new features. It's what we also call adaptive development methodology. It all starts with a new feature, and there is a like a planning team whose job was to plan that new feature. Then there was a design team whose job was to design new feature, develop a new feature, deploy a new feature. But the life of the tester was very difficult, right? So they not only had to deploy a new feature, they had to not only had to test the new feature, they had to also test the old features as well, so that to ensure that the new feature is not breaking up the old feature. And as the product started maturing, as more and more sprints, this agile thing is called sprint, right? So as more and more sprints started coming up, the number of features that a tester had to test started increasing. And eventually the life of a developer, designer, and the DevOps guys, their life was easy because they only had to develop and deploy only one feature. But the life of a tester was very difficult because in like a span of few weeks or sometimes few days, they have to test the whole product. And as new and new features piled up, that testing of those features became extremely difficult. So they come out with a solution that instead of testing each and every feature, why not automate the testing of past features and create new tests? So every time a new feature is launched, instead of creating a complete, like instead of testing the whole product manually again, they automated the test of past features and at the same time created new tests for new features, and based on that they completely automated their whole testing cycle. So that's how the automation testing evolved. And during the process, people started to decide, okay, now we have kind of automated our complete testing, but why are we testing at the end of every development itself, right? Why are we testing when the whole product is developed and then only we are running tests? Why not test every time whenever a developer commits a new feature? Why not test the whole product every time whenever DevOps guy deploy the whole feature? Right, so these automation tests were now being run not just once after like completing of every build, they were run at each and every stage. So this is how a complete CI/CD cycle looks like, right? A developer develops that code that is developed, it is committed in the code. That code is run and creates a build, and then that build is being tested. That build gets tested, and then it is deployed on stage, queue, and production environment, right? So we already automated the tests. So every time a new build released, a new test starts, the whole build gets tested. But then people realized, why not why not test the whole build even before it gets completed? Why not test the whole code when during the process of build itself? And not just we will not just stop there. We will test the whole code at every commit. Every time a new developer commits, it will automatically trigger a new test and see whether their commit is worth adding to the build or not, right? So earlier, when the testing used to happen at the very end of the cycle, now the testing is now happening because of automation testing. The testing is happening before and after just one commit. So the whole ecosystem of testing is now shifting left. There's also what right now is called shift left, right? People are now testing more and more at like a very early stage of the development cycle itself. So this is actually what the exactly continuous testing is. So it's a integrated part of your continuous integration and continuous delivery cycle, where each and every step of your product, each and every step of the development of your product is tested before it is tested again, like as a whole product, complete product, and then it is deployed and released to the users. So this all looks very good theoretically, but ultimately when we have to implement this process, it all get down to the tools that we are using. So during each and every process of this continuous testing, continuous integration, and continuous delivery cycles, people are using different tools whose job is to make out this process easier. So this all comes down to what tools that we are using. So for automation testing, there are multiple tools. There are like frameworks like Selenium, Cypress. There are also derived frameworks like WebDriver IO, Test Cafe. These are all automation testing frameworks, code-based. There are also codeless automation testing frameworks as well, whose job is to help you run your tests. And I will in fact show you how these tests are being run. But the first step that comes when we are running these tests is related to the browsers and the operating system, right? So let me showcase how this challenge looks like. So I'm gonna switch over to my code that I have. So I have created a very simple testing code. It is a Selenium code that kind of opens up a URL and finds the title. And if there is a this title is present in the in this code, it pass. Otherwise, it throws an error, right? So it's a very simple test. Opens up, runs in my simple machine, in my local machine itself. Let me run it. So it's a node test. I already have the node modules installed. So I have already done like npm install Selenium WebDriver. Also have a Chrome driver here. So test2.js. What it's going to do, it's open up my web page here, run a few tests, and perform whether the test is passed or failed. So there was an expectation that in my test, I defined an assertion that if the title contains lambdatest.com, then it's going to pass. Otherwise, it will throw an error, right? But the title did not contain lambdatest. It contained sample page lambdatest.com, so it threw an error, right? So I got this error. Let me close this. Let me change my test again. And let me run it again. All right, it ran perfectly. Awesome. We did one, we automated our test cycle. But the challenge first that came was this test only ran on Windows machine that is running the latest Chrome setup. Now I want to run this test on a setup that has, let's say, Chrome on Mac machine. How will I do that? I want to automate this testing over multiple different browsers, multiple different operating systems. I want to run it across different mobile devices as well. How to do that, right? So that's where platforms like LambdaTest came into the picture. So we are providing the platform of LambdaTest. We are providing you an online ecosystem that you can use to perform your testing across different browsers, different operating systems, and different browser versions, right? And the same test that I just showcased, this test can be run on LambdaTest platform as well. So I have another code here. This is the same piece of code. Again, I'm running the same, opening up the same URL. And in that same URL, I'm opening up LambdaTest, I'm running the same test. I'm checking whether the title is this or not. If the title is the same, it will do assertion that, yeah, the title is the same. It will mark it as a passed. If it is not, it will throw an error. But the difference here is that instead of running the same test at LambdaTest at my local system, I'm right now running my test at the LambdaTest grid. So what is a grid? Grid is an online collection of different machines that has different type of operating systems, and based on the capabilities that you define, like this is the operating system I want to run my test on, that test runs on that kind of operating system, right? So LambdaTest has nearly 2,000 different types of operating system browsers, browser versions that you can run your test on, and based on that you can define which operating system is you want to run your test on in like which browser you want to run your test on, which operating system you want to run your test on. So this same test right now I'm going to run on multiple different browsers. So I'm going to run on Chrome 86, let's say Chrome 85, Chrome 84, and Chrome 83. So same test case, I'm running on multiple different browsers, multiple at same time, right? So I'm also running the test as a thread. Let me run it. Node test. Now, what's the difference happening in between here and the test that I previously run? Earlier, that test ran and it opened up a browser in my local machine. Right now, that test is running up in LambdaTest machines, and it is opening up a LambdaTest machine, and the test is being happening on the LambdaTest platform itself. You will be able to see the running of your tests. And once the test is executed, you will be able to see the feedback both at LambdaTest system and of course the ID that you use to run the test, right? So in my case, my Selenium and my CMD command. So what happened here is now I have brought one set of my continuous testing pipeline to the cloud platform. Right now, the tests are being triggered even though at my local machine, but the test that is being executed right now, it is executed at the LambdaTest platform, and it is executing across multiple different browsers, and multiple threads are being run at the same time. So I ran 4 tests in the time of then the time it took to run one test earlier, and all those 4 tests were run across different operating systems. And if I can also, if I want, I can also have selected different operating systems as well, right? So I have capability generator here that can help you to create those capabilities, right? So what did I did different? So instead of calling the local WebDriver as I called in my local test, I called a local WebDriver that was building a Chrome WebDriver. I called a remote WebDriver, and again the Selenium capabilities that I imported earlier in my node test, that again includes the remote WebDriver capability. So I'm using this test on a server that is running on a grid URL that is running using capabilities that I have defined. It is building up the test and running the test. So the grid URL again I have mentioned here as a constant here. This is my grid URL, and to access this grid URL, I will need a username and an authentication key, right? And all of this you can find it at LambdaTest dashboard. If you go to sign up at LambdaTest, click on automation. This is the dashboard that opens up. Here you will find your authentication. You will find your hub URL, username, access key, and the next step is to define which browser version you want to run your test on. So you have to define the operating system, browser name, version, resolution, and there are few logs that LambdaTest give whenever you run a test. So these are also have to run. Also, you can toggle them using these capabilities. And at the LambdaTest dashboard, everything is organized by a build name and a test name, right? So if you do not define a build name or a test name, our platform automatically selects a new build name and a test name, but it's a random string, so it will become very difficult to see and organize later. So it's always best practice to define a build name and a test name. And all of this may sound difficult, creating a desired capability object. So we have created a utility for this as well that you can leverage to create a desired capability object, let's say in your specific type of code style. So for right now I'm using Node.js, so I can use this feature to create a capability for Node.js and then just copy paste this in my code. So I also running these tests in parallel across multiple different threads, and that is also cutting down my overall test execution time. So if I want to test these locally, I would have to like start them in a sequence, and they will take, let's say, 40 seconds to complete. If each test take around let's say 10 seconds, but here all the tests ran at the same time, so overall my test execution time gets cut down by a factor of 4 as well, right? And once a test is executed, we in my Node.js test here, I didn't got much of like the feedback here. If I was using, like, say, some kind of added tool, for example, if I was using IntelliJ or something, there would be a possibility that I may get a better feedback of my running test. But right now, to get to know how exactly this test happened, everything, we have LambdaTest here have given you additional logs. So what we do is we take a screenshot after execution of every Selenium command. So and at the same time gives a response like this was the parameter that was the passed and this was the response that we received. So it will make it a little bit easier to debug each and every test. We also at the same time provide end-to-end network logs. So to get a better understanding of what was happening behind the scenes, what elements opened up at which time, you get complete network logs as well. And we also provide Selenium raw logs. So to get a deeper understanding, do want to do a deep dive into Selenium, what happened exactly, which steps were performed and which steps were breaking, these logs will come in handy, right? And there are also console logs if there was any console error. So there was a 5-icon related console error that got logged. And so it gives you both a feedback that you get here in your IDE, and at the same time you get a feedback at LambdaTest platform as well. So you get best of the both worlds. And not just desktop, you can also run your test on mobile browsers as well. So you just have to select mobile capabilities, and based on that, you may be able to run your test on mobile browsers as well, right? And there are again added features related to the LambdaTest platform. For example, we have out of the box capabilities around geolocation that. So again, I will let you guys explore different type of desired capabilities that we have, and move on to the next part, right? So I have like successfully moved my one set of challenge that was related to browser compatibility to my cloud. So the again, the next set of challenge comes related to how to run this test itself in the cloud, right? So right now I am triggering my test using a local ID, that is my local command prompt, and the test is being run on LambdaTest browser. So one step is executing on the cloud, that is the execution part, but there is still the triggering of these test part that is not happening on the cloud. So how to do that? So this is the next step of my webinar, but before going to that, I want to take if there are any questions that I can help answer. So if you guys have any questions for me during this part till now, whatever I presented, I'll be happy to take them. Right, so I'm not just going to talk about LambdaTest, I'm also going to talk about how the LambdaTest platform also helps you bring your complete testing ecosystem to the cloud platform as well. So my next step is to highlight how you can run your test system, like complete testing system using Azure, and bring it to cloud, right? So that's covered. So right now, LambdaTest only covers related to Selenium and Selenium-based testing. If you want to do some kind of testing that is related to data science, it's up to you what kind of code you want to create. If that code has to be executed on a browser, you can do that. We do not have any out-of-the-box features around data science testing, but if that is something that you are looking for, like if that is something that you are executing through, let's say Selenium or Cypress or any JavaScript-based test, and you want a place to execute those tests, then that can be done at LambdaTest platform. All right. Anything else? Nope. All right, awesome. So my next set of challenge that I want to target was running the test itself on a cloud machine, right? So I want to still need a cloud machine that has the right setup that can be used to trigger these tests and then run them at LambdaTest. Or if not LambdaTest, like if you want to run it locally, then on that machine itself, that test gets run. And there is no dependency of, let's say, of a tester's machine in running the test. The testers do not have to worry about developing, maintaining, and deploying environments. They just get a machine where they can run their test, and that machine is also available 24/7. So that's where Azure DevOps comes into the picture. So let me showcase how Azure DevOps looks like. So I already created a very simple repository over here at Azure DevOps. So Azure DevOps is a complete package for your complete overall build management, test management, and everything. So there are quite a lot of features in the Azure DevOps itself. So of course you get boards where you will be able to manage and keep track of your projects. It's a project management tool. There is of course repo. So you would be able to manage your complete build, complete code structure. So this is a developer centric tool that will help you manage your complete code structure, manage your complete continuous integration cycles. And at the same time, there is also a feature called pipelines that will help you in complete your continuous deployment cycle. So not just integration, but deployment as well. So earlier I created a repo itself. So this repo has my same test that I just ran. And right now I ran this test over multiple different machines, but I triggered this test using my local CMD file, my local command prompt. Now my challenge is to bring that process itself to my to the cloud itself. And that is where Azure pipelines come into the picture. So once you have a build in place, once you have a repo in place, you can set up a build here. What it does is, let me give you a step-by-step process. So what it does it here, it will give you a workflow that you can deploy on a cloud setting. This workflow will complete your each and every step that you do before you execute every test. And this workflow will automate those execution of the steps that you do before execution of your workflow, right? So let's say right now I was running a Node.js test and I want to create a new workflow where every time a new trigger is being created in my main repository, it will trigger this workflow, right? So the first step to understand the workflow is to understand this YAML file. So this YAML file is important here. It defines how the workflow looks like, what processes you want to follow before that workflows happen, and what exactly stuff that you want to do using that workflow. So I want to kind of lot of stuff here is self-explanatory. For example, I'm triggering it whenever the main branch is being triggered. I can define which branch I want to run this test on. It will start a script. It will do an npm install. It will do an npm build. There is also a display name of that build that will be provided. So you will be able to see it when the tests are being run. But the thing here to note is the task part. So Azure DevOps pipeline has multiple tasks in place that will make your life easier, that will make setup of environments very easier. So right now I'm using a pool of VM images. So Azure also provide you as parts of Azure pipeline a set of machines over which you can execute these builds. So they will provide you machine like Ubuntu latest. There are also Windows and other different type of machines available as well. So you just have to check out their repository, what kind of machines they have, check out their documentation. You will be able to find multiple different kinds of machine. I'm right now using Ubuntu because that itself helped me out. And I also, because my test is running using Node, I am using a task that will set up a complete Node installer, right? So Azure has already been kind enough to provide us a single line way to install the complete Node package across the machine. And using that, I can run my NPM based test, right? So there are like thousands of different things that you can do using just this YAML file. And if you are a DevOps guy, you can configure like your complete workflow using just this file, using these tasks that are present. But for me right now as a tester, like not a lot of stuff is needed. I just need to automate my one simple step of running my test, right? So that's what I'm gonna do. I have another repo in place where I have already created this YAML file for my testing itself. So again, I didn't do much difference here. Again, I'm running my test on my on a VM image of Ubuntu latest. I am installing Node, and at the same time, I'm installing the latest version of Node itself, right? And there is also a check here that I've added to ensure that the version that I'm installing is the latest one. I am running in clean install. I am building up, and I'm also running a server. This was not really necessary here, but I just ran as a way to test it out. And I'm running my NPM test, right? So a quick heads up here, like that before I ran this test, I defined in my package JSON the value of test that I want to run a unit test, and that unit test is test.js, and it is present here itself in the root folder itself. And I'm gonna run this as a pipeline, right? So what exactly is this pipeline? So every time I commit something in this repository, this pipeline gets triggered. And every time this pipeline gets triggered, it follows the processes that I have defined in my YAML file, and based on that, it provides me a result. So for example, let me do some kind of change here. Edit testing my workflow, and I click on commit. If I didn't want to commit, I can also create a pull request kind of thing. But right now, commit itself would work for me. I have just created a new commit, and that commit would have triggered a new pipeline just now. So this new pipeline has been triggered, this new job has been triggered, and it will follow all the steps that I have defined in the YAML file. That means that it will start up all the job parameters. It will start up a new hosted agent that is a new Ubuntu machine. It is now installing Node.js. This is again Ubuntu machine provided by the Azure Cloud by Microsoft itself, and now it is running my Node.js tests. And you will be also able to see the feedback of these running tests. Again, right now I'm executing those tests at LambdaTest platform, so 4 tests are running right now. And once those tests gets executed completely, you will be able to see a feedback over here in your Azure pipelines. Right, see all tests done. You get a OK report that yes, everything was working perfectly, and now like you can successfully commit your test itself, right? Succeeded. So instead of creating a new test request, like new commit request, I could have created a new pull request, and that pull request would have triggered this again pipeline itself, and will have highlighted if anything broke down. It would have been highlighted in the pull request that this pipeline was run, and this pipeline was not running successfully. There was some error. You may have to check your pull request again. You were breaking something. Right, so now what this did it, now I have successfully brought my triggering part as well to my cloud platform. Now the tester would not have to trigger their test on their local machine. Now they have also running those tests over a cloud platform. Integrating this with LambdaTest, the major the major pro here of running the test here at LambdaTest was that I do not have to create a steps to install Chrome or install the browser in my Ubuntu machine, right? Because I just had to install Node and run the test, and that test was executed on a browser that was installed on running on LambdaTest platform. So I do not have to follow the complete step of first installing the browser and then installing the driver to run that test. I just have to initiate the test, and the test got executed in the browser of my choice. I did not have to worry about maintaining these YAML files based on the different browsers. I did not have to worry about maintaining different type of VM images. So for example, I right now those tests ran on a Windows environment, even though the machine that I used here was an Ubuntu machine. So that gave me an added advantage of becoming independent of the type of infrastructure that I have available here as well. So those were added advantages here. And so right now I just ran a node test, but not just node. You can also create new type of pipelines based on different type of environments. So for example, if I wanted to run, let's say a Java environment, I could also do that. I could run an Android environment as well, .NET environment. So based on the type of test that you have, you can select a specific set of tasks, and the platform will automatically build up, at least give you a starting point from where you can build up your next journey, right? So there are, again, as I said, thousands of things that you can do just from this workflow YAML file itself. So yeah, so this kind of there are multiple different feature sets in Azure DevOps itself. For example, there is a way to manage and keep track of your like your manual tests. You can create your complete test plans. You can create your progress of these test plans here. But right now, I just focus main on the pipelines part, right? So this kind of concludes this part. Now, my next step would be to run this same kind of setup over the GitHub Actions. So GitHub Actions is quite similar to the Azure DevOps pipeline, and I would be running them over over GitHub Actions as well. But before I do that, do let me know if you guys, anybody has some kind of question for me. Does LambdaTest uses Selenium on all supported platform? Yep. So we do have Selenium as well. We do have Cypress, or we do have Test Cafe. So we have all different type of browsers, browser versions, operating systems that you can run your test on. So for example, if you can come here, desired capability object, you will see we have Windows, Mac machines, and even in, let's say, Mac, we have different type of browsers, browser versions. So we have a ton of different type of environments that over which you can run your test on. And all of this is maintained by us, right? So you do not have to worry about what's the Selenium version that you are using. You do not have to worry about what is the like Chrome driver version. So in my workflow, I did not define any Chrome driver. I did not define any Selenium version. I just did a package install of the latest Selenium WebDriver, and I could have. I did not have to worry about the operating system as well. I did not have to install any specific kind of operating system set. So if I just had to do this from the scratch alone from Azure DevOps pipeline, I could have done that as well, of course. I could have installed the complete browser. I could have installed all the dependencies and then then could have executed the test. But that's added hassle, right? As a tester, I do not want that kind of hassle. So I've just integrated it with LambdaTest platform. Anybody else? Nope. All right, so I'm gonna replicate the same kind of stuff here with GitHub Pipeline as well. So as you know, Azure DevOps and GitHub are both products of Microsoft themselves, and they have done quite a similar things across both the products. So Azure DevOps has an added advantage that it's a complete package. It is a complete way to complete, manage, deploy, execute all your tests, and bring your complete complete ecosystem to a single platform. You can manage your test, you can manage your project management, everything here. And that same kind of thing can happen here at the GitHub as well. And there's also a very deep integration between Azure DevOps and GitHub. So you can instead of right now in my Azure DevOps account, I created a new repo. Instead of that, I could have created a new repo based on like I have created a new repo directly from GitHub itself. I could have entered a GitHub repository URL, and from there I could have pulled my GitHub repository directly here as well, and integrate both Azure DevOps and GitHub. So any commit right now that I did in this repo, similarly any commit that I could have done here in the GitHub repo, that would have triggered the Azure DevOps pipeline. The only difference would have been that this YML file here would have been created in my GitHub repo, and whenever I like create a new commit or create a new pull request, that would have triggered a new build pipeline in Azure DevOps. But the same kind of setup that I did earlier, that same kind of setup can be done here as well. So in my new Azure, in my GitHub repo here, I have added all the same files. I have added the test file, my package JSON, and the package log JSON. And whenever I want to create a new workflow, that is done via what we call action. So what I'm doing here is I'm again creating a what in earlier here it was called pipelines. In GitHub here it is called GitHub Actions. So I can set up a new GitHub workflow. Again, because I'm using Node.js, I'm using the Node-based GitHub workflow, right? So let me set it up. It will again create a YAML file as well. So the difference here is that there is a very huge difference in the syntax of the Azure DevOps pipeline YAML file and the GitHub's action pipeline here, right? So right now they have few stuff is same, the name is same name. The trigger here right now I have defined on push or pull of branches main. Here I just defined trigger main. So the steps that are happening are kind of same, but the way of running those steps is a little bit different. I'm running a job build. I'm running on Ubuntu latest, same. There are multiple different type of machines available here as well. I could have run this on I could have run this on Windows. I could have run this on other versions of Ubuntu, other versions of Windows as well, based on the type of environments that are available. Again, I am using a Node version, and the difference here in Azure DevOps and GitHub Actions is that GitHub is using a thing that we call actions. So GitHub has predefined actions that help you set up your environment. So it is helping me set up a Node environment. It is helping me set up a learn a kind of an actions environment for a complete setup of Node. So here I checked out the Node, here I have installed the Node, and based on the Node version that I have defined here, it is doing a complete clean install of that Node version, right? And once I have run the clean install, I have performed the build, it will run an npm test of the code that is already available. So again, I do not have to do much here. I just have to define I want to run this on 16.0. The one of the latest versions of Node that I want to run my test on. I am running npm clean install, run test, start commit new file. And whenever I do some kind of edit here, let's say I want to do some edit. Hello world. Ready world. Instead of creating a complete, earlier I did a complete commit. Instead of right now I'm creating a new branch. Just creating a new branch will trigger that GitHub action, right? Just creating a new pull request will trigger that GitHub action that I just created. Give it a few seconds. Yep. It created the GitHub action, triggered the GitHub action. And again, it will do the same kind of steps that I defined, right? It will set up a node machine. It will set up a new environment. It will check out all the stuff that I did. All right, so it gave me an error. there was an error related to the username and access key and is invalid. Okay, so in my test, I didn't validated my access key and gave an error. So that in fact, that's a good thing as well, because earlier I didn't got a chance to showcase what happens when there was any error. So I just got this error and GitHub has highlighted me does this pull request. There is an error in this pull request. So it's up to me if I want to run this pull request or if I want to just close this pull request. I do not want to merge it. I will just close it. And based on the challenge that I just received, there was an issue related to the username and key. All right. So another thing that I wanted to highlight is a feature called secrets, right? So earlier in my Azure DevOps code that I just ran related to the test, I did one very dumb thing. I did opened up my username and my access key here, right? And if you are running, let's say on a private repo that has like very few accesses, then that's okay. But a good set of security practices never to expose these kind of stuff over a public setting, right? Over a repo that may have access to multiple that may have that is being accessed by multiple people. You do not want to expose these kind of stuff over there. So instead, what I do is I will define a security, what I will call secrets here that will create a variables repository secrets. So I go to settings in my GitHub repo. I click on secrets. I create a new repository secrets. And in this repository secret, I define my username, right? So earlier, as I mentioned, you can get your LambdaTest username from this place here. So I'm copying my username. I've added a secret. I am going to create a new repository secret that is going to save my access key, username key, add secret, and these secrets have now been stored for this repository. So my next step is to ensure that whenever I set up this build, these keys are being used. So to use these keys, I have the best process is to make these security keys as part of environment variables. So I want to set up these keys itself as environment variable, and whenever I run my new test in a new machine, these keys would have to be set up as an environment variable, right? So to do that, again, I have to go back to my YAML file. So I already had a YAML file similar to this already created before. I'm just gonna copy paste it. Environment variable and test. So there's a difference here is that right now I am just naming my this convention here, and I am setting up an environment variable. And whenever that environment variable is triggered, it will create a LT username using secrets. It will create an LT key using secrets, and then we'll run a test, right? I think I did some kind of error. Run. In steps. Start commit. I created the commit. Let me see if I created the GitHub action or not. Yep, it created GitHub action, triggered a GitHub action. Let me see whether this time it passes or not. Again, all the same commands that happened earlier, they happened as well. Oh, okay. So I did a very small error earlier as well. I was creating in my test a tunnel command that I didn't have to do. All right, I found one more error. Let me turn it off. Create a pull request, propose changes, create pull request. It will trigger another GitHub action. Oh, damn. All right, so it is opening up my test that is being run. Okay, because this thing has not been defined. I have to define it. Sorry about that. So I defined the tunnel capabilities across multiple places. I forgot about that part. So the tunnel capability that I've been turning out off right now is used to define is used to run your test on a locally hosted page. So if I have a page that was not hosted on, let's say in a public URL, I want to test that page. So I can, which is hosted on, let's say localhost or hosted on a privately hosted setup, I can use that tunnel action like tunnel capability to run my test across different tunnels, right? All right, so I ran a test. There was an error related to assertion, and it gave me the error here directly. So again, this is, I will say this is a past workflow because it highlighted the test that I wanted to do. So my test wanted to check whether the page has the URL here that I was using was a localhost URL because I used to run a tunnel earlier, and it did not have this kind of title in the localhost page. So it gave me an error. So the reason I was using localhost here was because I forgot to showcase one another important aspect about the Azure DevOps part is that it will also do a complete build of your system, run that build, and over that build you can run the test, right? So earlier all the tests that I ran, they were using a locally host URL that was available publicly, right? I was running a test on a URL that you can open up and you can run a test that is available publicly. And based on that, everything was happening perfectly. But then there comes a challenge. So the challenge here is that every time I want to run a test, I will want to test the web page before it hits live, before if it hits in the public setting, because I do not want to want the rest of the users to see my mistakes. So I want to run a test that happens before the URL is public itself. So what to do? So the quick run here would be that I build a complete build over the GitHub itself. So in the workflow itself, I defined that used my GitHub repository as the build and run up a tunnel inside the build, and using the tunnel, I test that locally hosted file. So the tunnel is a very simple LambdaTest utility that can be used to test your locally hosted and privately hosted applications. The tunnel is available across different type of we have different type of flavors as well. There's an NPM package. There is a downloadable desktop utility called Underpass, and there is other different type of binary files as well that you can use. But the best part related to GitHub Actions is that we have a defined GitHub action to run your tunnel. So to run a tunnel in my GitHub Actions, I just have to define one single line. That is that I'm going to run a GitHub action tunnel. This is the line that I have to define. It will create a server. It will create the build, and it will again use my authentication key and password that I defined earlier. And that would be added to the test that I run, same, and it will create a complete workflow using the tunnel itself. So what is happening here in this test scenario right now is that my YAML file is opening up my build, the code that I've added in the GitHub, and using this code, it is creating a complete build and then installing and running that build on the machine that GitHub is providing us, and then testing that build over the LambdaTest platform. So let me in fact trigger a test here. That will give you a better picture how that is happening. And instead of creating a new pull request, let me testing propose changes, create a pull request. And again, a new pull request has been created. This will again trigger a new workflow, but this time I'm doing a lot of stuff. I'm creating a new server. I'm creating a new build. And at the same time, I'm also starting a tunnel. So once I start a tunnel, I will be able to see a feedback here at LambdaTest platform as well that I have a tunnel in place. I have one active tunnel and that is running test using these tunnels. That is running test of my locally hosted pages, the page that was hosted locally. See, it was hosted locally, localhost got executed very fast. It executed locally and then it gave me the results of those tests, right? And right now everything was completed. In my commit, I will see pull request. I will see that, yeah, there's a pull request and everything related to that pull request has passed. There was one successful check. It passed. There was no branch conflict. Now I can merge pull request. And the best part is that I have created my GitHub actions for every type of action. So not just on pull request, on the merge as well. Whenever I create a merge, it will also trigger a GitHub action. So even though the test may have passed before the pull request has been merged, but once the merge has happened, it will again run a test and it again will give you an idea whether the test is running perfectly or not, right? So what is the added advantage of GitHub Actions is that I will say that it has personally speaking, it has a better workflow. It has a more easier to understand workflow, and there are tons of third-party actions available that you can leverage to run your GitHub Actions. So it's a complete CI/CD cycle that also supports your testing part in a setting that is more convenient to your daily use, right? Most of the people are very used to the GitHub Actions. So yeah, so that's what I wanted to highlight related to GitHub Actions. Let me know if anybody has questions for us. So Lambda tests can also be used to test for API contact listing. So right now we do not have we do not have to we do not have API testing or JSON testing features available out of the box. So but again, as I said, we will provide you environments and way to run your test. So if your Selenium script or JavaScript based scripts uses some ways to using APIs, or you are validating these APIs somewhere in your tests, you can do that. But out of the box, we are not similar to, let's say, Postman or something like that. That will help you in your API testing. Right? Is it possible to configure email once every test run is finished in Lambda test with execution results? So yeah, so once every test is run, you will get a lot of data related to build. So you will get an email of these test executions, and at the same time, you can also download the report of your overall test execution. And we also have APIs. So we also have APIs that you can leverage to like extract all this data. So all the logs that I showcased, statuses, pass, fail, everything you can extract using our APIs. If you are using any custom, so again, these APIs can also be defined in your Azure or GitHub workflow, like set up a machine that extracts all of this data using APIs after the test and executed, and push these data somewhere, like in any other repository that you have. Environment variable. So here again, environment variable I defined here in my GitHub Actions using secrets. So I think that part is kind of covered. Any other any other question that I'm missing out? Nope. So yeah, so I'm gonna move on to the next part, that is a very brief introduction about how Microsoft ecosystem is helping nearly all teams. So earlier we saw that nearly every aspect of your testing and development cycle can be done using some form of Microsoft products, and that includes features like Azure DevOps, GitHub, and of course Teams as well, right? So LambdaTest has an integration with Teams, and a lot of data that we just created, like all the GitHub actions, can be triggered to get a summary back on the Teams itself, right? So we can also trigger different type of tests using Teams itself. So there is an integrated ecosystem of for testers and developers using both features like platform like LambdaTest and platform like Azure DevOps. So the ideal scenario is that there is integration between each and every system, so that the feedback of action performed on one type of system happens and gives you a feedback on other channel as well. So for example, in LambdaTest, whenever I run a test, so I have defined, we have an integration with Azure DevOps, right? So let me in fact showcase it. So we have a manual testing feature as well that you can leverage to perform tests on different browser for a website on a different type of browser version operating system. You can perform manual tests. We will provide you a machine over which you can perform live interactive testing. But the best part here I wanted to highlight is that you can mark as a bug here. You can find any bug, let's say, and then mark this bug directly to a project management tool. So right now I have integrated with Azure DevOps. So anything that I test will go to my Azure DevOps board. It will go to my I will assign a priority, it will go to an iteration, and it will also be sent to the Microsoft Teams, right? So once I create an issue here, this issue will directly go to both my Microsoft Teams and it will also go to my Azure DevOps board. Give it a second. Bug have been marked perfectly, and in my Microsoft team I can see, yeah, this is a new issue that was created. I also got which operating system browser version this test was run on, and using this link I can open up this again, same configuration in the same machine. So what will happen here is that it will save the time of a tester to open up that particular configuration and URL, right? So this is the type of integration that I'm talking about. This is the type of an ecosystem that you get by integrated multiple different tools together and get a same feedback of that type of tool across multiple products. And this happens here as well. So you can integrate your GitHub and Azure DevOps, and based on that, you can get feedback of any build, any commit that you do on Azure and on your GitHub repo. It will trigger our Azure pipeline, and that kind of integration will help you out in the long run to make your overall testing to a cloud process, right? So yeah, so that kind of concludes my most of the presentation. So I will right now open up the floor to any questions that you may have. Okay, I also wanted to highlight that Microsoft is like Microsoft Azure is not just limited to Azure DevOps. It has like tons of different features for like different set of works. So if you are a DevOps, if you are a developer, if you are a tester, there's something for you out there in the Microsoft ecosystem to help you in your test, right? So yeah, so I will, if you guys have any questions for me, I'll be happy to answer them right now. Yes, so if you have an Chrome extension, you can also test your Chrome extension as well. At LambdaTest manually as well. So if you go to LambdaTest platform, select a browser, let's say Chrome browser, the only caveat here is that you would have to perform those testing, like you have to install those Chrome extension every time a new test is run. So this happens both at LambdaTest, at Azure, at GitHub Actions, everything. So once you get a machine, that machine is assigned to you, but once your test gets completed, yeah, or once your build gets completed, that machine is completely erased. So that machine is completely destroyed. It is a security settings, so that way whenever that machine, let's say, is assigned to anybody else in future, that person will not have the same session access, right? So this happens in GitHub Actions as well. This happens in Microsoft Azure as well. So and it happens at LambdaTest platform as well. So once you complete a test, that machine is completely erased and destroyed. And so you would have to run this whole process again. So you would have to start a test, install the Chrome extension, test it, and once you close the session, and start a new session again, you would have to install it again, right? So that's a step that you may have to do. But if you are running automation, you can do the installation part as part of the workflow. So you can set up a Selenium, like Selenium script. You can set up pre-run executables, or you can set up using YAML file itself. That the step is to install a Chrome extension and then run a test. Anybody else? Let me know if I'm missing out on any question. Nope. I think, Rashmita, it's now over to you, right?
Yes, thank you, Mudit. We still have some time before I close the session. So in case if you come up with some question, please feel free to talk. Mudit is here, so he can take up questions. So thank you, Mudit, for the session, and thank you all for joining us today. I have shared a link to our feedback survey in the chat. Do send your feedback. It will help us curate topics that better suit our audiences. Also, if you would like to watch this session, a recording will be uploaded to our YouTube channel in the coming days. For more sessions, please visit our Reactor Bengaluru website link. Thank you, Mudit, and thank you everyone once again.
Yeah. Thank you, Rashmita, for hosting this, and for the Microsoft team for arranging all of this and hosting this, and look forward to more reactive events as well, and look forward to the recording as well.
Sure. Thank you, Mudit. Thank you, everyone. Signing off.
Have a great day ahead, everyone, and stay safe.
Yeah, stay safe. Bye.